How to convert decimal numbers into fractions. First, we need to know that we have two types of decimal numbers. The first is a decimal number that ends after a comma. So we call this a determinating decimal number. And a determinating decimal number, for example, we have 0.25, we can have 0.375. So if a number ends after a comma, that is a determinating decimal number. So it ends, it stops. But when we talk about a recurring decimal number, we talk about a decimal number that continues to infinity after a comma. For example, we can have a value of 0.33 moving on like that to infinity. So that will be a recurring decimal. So now a recurring decimal, it is represented like this. We have 0. So if a number repeats, we just put a dot on top to show that this number, it repeats up to infinity. So now you can also have recurring numbers that have different numbers that repeat. For example, you can have 0.121212. So you see now this pattern is continuing like that with 1212 after a comma. So we can also write this as 0.12, and then we show that the 1 and 2 are recurring. So that is a difference between a determinating and a recurring decimal number. So now let us learn how to convert these decimal numbers. If we have a determinating decimal number, for example 0.25, to convert this to a fraction, you're going to look at how many numbers does it have after a comma. So in this case, we have 1, 2. So you're going to divide by 1 with the number of zeros that we have after a comma, of which is 2 zeros. And then we have 2 decimal numbers after a comma. So that is why we have to divide by 100. So 2 zeros represents the number of values we have after a comma. So now, what we're going to write at the top is we're going to move this thing that are after a comma to the left of the decimal. So this is just going to be 25 in this case. So that means now 0.25, it is the same thing as 25 over 100. And then you can put 25 over 100 in your calculator to simplify it. And then this will simplify to be 1 over 4. So now you can have a decimal number like this to say 1.375. How can you write this to a fraction? So remember, the first thing that you do, you look at how many numbers do I have after a comma. So I can see I have 3 numbers. That means I'm going to say 1 and then write the 3 zeros because we have 3 numbers after a comma. So but now all the numbers after a comma, they're going to move to the left like this. But if you look at this, we already have 1 here. So we're going to start with 1 and move the 375 to that side. Then we put it on the top of the fraction. So now to simplify this, you can just simply put that in your calculator to say 1,375 all divided by 1,000. And that is going to give us 11 over 8. So that is how you convert what? The determinating decimal numbers into a fraction. So now let us look if we have a recurring decimal number. So let's say we have 0.333, that is recurring up to infinity. So now how can we convert this to a decimal number? What we usually do, we actually let this value that we have, that is given to us, to be x. So we're going to say let x to be equals to 0.33 recurring like that. And then now we're going to find a way to actually make the decimals to be the same after a comma. So in this case, we can just multiply this by 10, and then we will still have the same decimals after a comma. So we're going to say now we have what? We have 10 multiplied by x, which is going to be 10x. And then if you multiply this by 10 here, you're going to have what? You're going to have 3 move to the other side one time because it's 1, 0. And then you have what? You have 3, 3, 3, moving on like that. So you see now we still have same 3s that we have before. So now after we do this, we're just going to say 10x minus x is going to be the same thing as this minus that. So the reason why we multiplied with 10 is so that we have the same decimals after a comma, so that when we minus this out here, it's going to cancel the decimals. Remember, the aim is to get rid of the decimals, and then we write our number as a fraction. So this is what is going to happen. You're going to have 10x minus x. And therefore, remember, what corresponds with 10 is this value here. So we have 3.333 recurring minus 0.333 recurring like that. So now what is happening is that on this side, when we minus 10 minus 1 is going to be 9x. But on this side, when we minus, we're going to say 3 minus 0.333, all those, the digits after a comma, they will all disappear. And then we have what? 3 minus 0, which is the same thing as 3. So the reason why we multiplied with 10 is so that we just have the same pattern after a comma. And then the reason to have the same pattern is because it will cancel out, and then we're just going to be left with a integer number. So now we can simplify this to say now we can divide both sides by 9, and therefore the value of x will be 1 over 3. So we have converted this recurring decimal number into a simple fraction. So we can have a lot of different decimal numbers. For example, if you have maybe a decimal number that has 2 digits that repeats after a comma, if we have 13.121212 moving on like that. So now the question says, can you please write this as what? As a fraction. So what you're going to do is that you're going to say, okay, I'm going to let all this to be x. So you're going to let what? You're going to let x to be equals to 13.121212. So remember, this value repeats to infinity. So now the aim is that I want to multiply this by how much? By 100, because if I multiply by 100, I'm going to move the 2 units to the left like this. So if I move 2 units to the left, I'm still going to be left with what? With 1, 2, 1, 2. And then originally I had what? 1, 2, 1, 2. So 1, 2 and 1, 2 will cancel out as decimals. And then I will be left with what? With the whole numbers. So now let us first try to multiply this by 10 to see if this will work or not. So now we're going to say 10 multiplied by x. And therefore, if you multiply this by 10, it's just going to move 1 unit. So you're going to have 131.2121212. So now, do you see now, if we have the value that is starting with 2 here, when we minus the 2 values here, we are not going to have this thing cancelling with that thing because they are not the same. We need it to be 1, 2, 1, 2, 1, 2, the same as it is at the top, so that when they cancel out, they can minus completely. So if this is the case, that means we also have to move the 2 to the other side up until we have the same pattern that will cancel out when we minus. So you're going to say what? 100 multiplied by x. So now 100 multiplied by x is going to move the 2 units to the left. So you're going to have 1, 3, 1, 2. That means 2 units has moved to the left. And therefore, what are the commas or the decimal number that you have after a comma is going to be 1, 2, 1, 2, moving on like that. So now, do you see now, if we look at the x and the 100, after a comma here, we are having the same values, which is 1, 2, 1, 2, 1, 2, 1, 2, like that. So now, if this is the case, we can therefore say what? 100x minus x. And therefore, this will give us what? 1312.121212 minusing with what? With 13.1212, moving on like that to infinity. So now, remember, when we minus on this side here, can you see that these things will cancel out? So if these things cancel out, therefore we can just minus 1312 with 13 so that we get a whole number. And then on this side, we're going to say 100 minus 1, which is going to give us 99x. Okay? And therefore, if we have 99x, we can say what? We can say 1012 minus 13. So 1312 minus 13 is going to give us 1299. So because we know that already the ones that are coming after a decimal, they will cancel out because they are the same. So now to get the value of x, we divide both sides by 99. So the value of x will be what? You just put that in your calculator. You say 1299 divided by 99. So the answer that we get is going to be 433.33. All over 33, I mean. So this means that we have converted this a decimal number into a fraction. So that is how you convert what? A decimal number into a fraction. Thank you very much.